All right, welcome everyone. Very good morning, good afternoon for joining from different region, or good evening. Today we are going to do a paper reading. It's a session around Gecko, one of the Google's DeepMind model, um, primarily famous for text embedding architecture, text embedding, model. So we are going to deep dive into this, and let's talk about how this embedding model works. Before I go there, I'll quickly introduce myself. So I have around 13 years of experience in the industry. I have been working on various technologies, especially in the deep learning and the data engineering area as well. And I've worked with various clients, currently working at Salesstrat for leading generative AI solutions. At Salesstrat, we have various products. One of our flagship products are like ImagineView. You guys can sign up to imagineview.com/sign up. You can look and also subscribe to some of these products like Cellbot or Knowledge Miner, just to have a understanding of using RAG and advanced LLM features. Okay. All right. So welcome everyone, and let's get started. So I would like to set this pretext here. This model, which is Gecko, got published, the paper published in 2024 March 29th March, just 2 weeks back. And the idea behind reading this paper session, or I like having a paper reading session, is more like a sharing and also interacting with the audiences. So if you are joining from whatever background you have, already have some understanding of deep learning, or if you have good understanding of deep learning and some understanding of LLM, that's good to have for this session, because these are like slightly advanced topics that we generally cover on these kind of sessions. So I would expect that you have some fundamental knowledge, because given the timeline for an hour session, it is difficult to go deep dive into a specific area. But I will try to answer as much as questions possible, and we can also trigger some discussions there as we go. All right. So yeah, so thank you everyone, and let's get into it. So Gecko is one of the I would say, before I go into this, so are we all like have seen different embedding models, and I think all of us are aware of what is an embedding, right? Can anyone quickly tell me what is an embedding? If you can. What is an embedding? Maybe we can ask this question in this way, that what is a vector, right? What is a vector? And that vector actually creates embeddings. So if I understand this vector concept, which is like, normally if you see, vectors are one-dimensional matrix. Okay, one-dimensional matrix. So in a one-dimensional matrix, I have a shape as 3 here, and this is a 1D matrix. I can have multi-dimensional matrix. I can have multiple sizes of these vectors. Now, how do we get it? So, and what do we do with it, right? Embeddings are primarily built for um, understanding the textual features. For example, it is not just textual, but it can be any other form of data, but it is primarily in the NLP domain. It is on the textual information. That means if I have to understand, or if I have to correlate two different strings, or two different documents, or two different paragraphs, I need to have an embedding built on that paragraph. That embedding actually gives you the model an understanding of the context, right? The I mean, although the everything that about context doesn't come from embedding, but it's one of the important aspect that the a root of any LLM that we see today. Okay, so bit of background here. How do we actually start building embeddings? how did we start building embeddings? If we, if we look back, like we had one hot, very primitive. Now we don't use one hot. From there, we came to, let's say, word to vec models. From there, we came to some of the models like GenSim, which are more advanced, GenSim, fast text. Um, and then from there, we came to BERT, kind of. BERT is the first model that started using contextual understanding in the vectors. And from there, we came to GPT and GPT based models. Now, if you see today, if you all have used GPT 4 or GPT APIs, it comes with an text embedding model, isn't it? Text embedding model. Have you seen that? I would expect some interaction here, guys. Yeah. Okay. Rahul is saying yes. Yeah. So we have seen some of the text embedding model that comes with this um, embedding, or sorry, LLMs that we have seen so far. All right. So why do we need these text embedding models? In very layman term, we can say it takes a word. Let's say I have an embedding model. I can take a OpenAI text embedding model, and I get vector out of that. Okay, this is what is the purpose of an embedding model. Now, how does it help? How does a vector help? So if you look at this, there are, like when we used to create using the techniques like, um, we used to create like one hot encoding or TF-IDF, they were fairly doing well, but they used to create sparse metrics, as well as there is not much information that we can capture in those sparse metrics. The more denser the vector is, the more information you can carry. And also, if we can reduce, like if you can reduce the size of the vectors, we can also reduce the amount of memory it is going to use. Thus, we can improve the model performance and also the amount of data that we can train with these models. Does that make sense? So an efficient embedding model is very, very helpful. And that's why we came up with word to vec, BERT, and those based models based embeddings. Now, this is what is kind of, you can say, is, we used to see in the TF-IDF world or bag of words models. And then from there, we came to models like dense vectors, which is, you will see something like this, right? An example of a vector. So you have not much zeros, because zeros doesn't carry any feature. The feature that is representing a particular word or a sentence or a document. Okay, so so we convert words, let's say cat, into a vector. So that is what is word to vec. We can also convert a single character into vector. That can be cat to vec, but not that popular and not that useful in a lot of cases. We can convert a document, that means a whole document file or paragraph, that we can call it a doc to vector, and we can have sentence vectors, etc., etc. So there are different models that came in over the time, like sentence transformers, which are more like vector embedding created based on phrases, a little bit longer, you know, I would say sentences. Instead of one word, there's 3, 4, or 5 words, right? Depends on the size that they define for the embedding of the models. Okay. So this is just a background about the embedding and how it came and how it evolved. And now we see that everything that we do with LLMs requires an embedding. Now you can see that what is the dimension that, so dense vectors are still highly dimensional, and there are 784 dimensions that are common, but it can be more or less. It depends on how you build that particular vector. However, each dimension contains relevant information determined by the neural net. So the neural network, underlying neural network that is used for building that vector, is defining the vector dimension. For example, when BERT was introduced with transformer, it was 512, the dimension of the vector was. And then later on, we improved it. And maybe let's say we went from 1K to 4K dimension. And that's why you say 1K to 4K context size. And now we see 120K or 200K context sizes as well. So it actually matters a lot with the vector dimension that is being used here. Okay. So all right. So what do we do with after we get the vectors? We understood how we improve on different type of model versions over the time to get the embeddings. Dimension is the size. I mean, not. I mean, we can say the size. Yeah. Yes.
And that's it, one quick question. Does context length has to do with the vector embedding length?
Yeah. So basically, if the vectors are the embedding vector that is being fed into the model is shorter, then you cannot really go beyond that. The context cannot go beyond that, right? So it has to do a lot of things with the embedding vector, of course, the dimension of the vector. Okay, the context length. All right. So like in the BERT world, we used to have 512K is the vector size. So we cannot go the context cannot go beyond that. So there were some different techniques to do that, to improve or to increase the size of the context, but it is majorly dependent on a lot in the embedding vector, yeah, dimension. But it's not like you can say if I have 200K vector dimension, that means I'm going to, 200K context, that means I am going to have 200K vector, right? Not like that. Not exactly the same. So I will talk about that later on. All right. I think there was a question in the chat about what is vector dimension. See, dimension, we all know about, like a vector can be an n-dimensional vector, right? ND is, so if I say this example, this is a, can you tell me, this is a 1D vector, isn't it? One-dimensional vector. The dimension, similarly, if I have not a vector, but I can have a matrix. For example, let's say I have something like this. So I can say it is a 2D matrix. Okay. Yeah. What's the question? Gauravish?
Yeah, so I guess you mentioned that similar words are going to be grouped together, right?
Ah,
That is what you mentioned.
correct.
Yeah.
Yeah.
Yeah. So there is a high possibility of like some words in a document being grouped for a particular use case, and the same words will be have to be grouped for another use case, right? So wouldn't that cause like a disturbance? Like for one document, you're referencing these type of words in a particular section, and for the other document, you're creating another. So wouldn't that cause disturbances?
Okay. Very good question. So let me explain this quickly. Okay. So let's say I have disturbance in the sense that everything depends on what you are requiring. So let's say I have a bunch of vectors here. Okay. So I have a cat, which is converted into vector. I have a dog, which is also converted into vector in a in-dimensional vector space. And I have an animal. Okay. So now this, what it will return from this set of vectors. I mean, I have many vectors here. Maybe they are converted based on their contextual nature. So now I'm looking for a wild cat. Okay. I'm searching for a wild cat. Okay. So maybe this cat, which is, we can see as in word, but it can be a whole context together. So if I'm looking for a wild cat, and ultimately this is a query. Okay. This is a query. So now I convert this into a vector. Okay. That's the normal approach. I mean, if you ask me why, but this is the normal approach. So now if I convert this into vector, can I look for similar vectors here? Can I look for similar vectors here? Parvesh? We can, right?
Yes, we can.
So now maybe a wildcat is not directly matching with what we have here, right? Because maybe I have cat, dog, and etc. etc. But let's say these are converted from a lot of paragraph, right? And we got them into converted into tokens, got the embeddings for that. So now the embedding vector, which is a model actually, let's say embedding vector model, is allowing you to pass a sentence to it, right? And convert that into a vector. Now I have a big paragraph about a wildcat. Okay, that talks about a story about a wildcat and so, right? Now I'm looking for a wildcat. It looks for, now this, 1 minute before I explain again. So what we do is, today we store them into, let's say we split this big story into smaller sentences or paragraphs, and we convert them into vectors. Okay, we convert them into vectors, and similar way. And so on. Okay, so now I'm looking for a wildcat. So I can have a sentence that is containing similar kind of context that I'm looking for. Can I get that sentence, or can I get maybe merge two or three sentences that I'm looking for, and I can create a paragraph? Yeah,
Yes, we can. But I guess all of these sentences will itself be far apart, if I'm not wrong,
all of the sentences in the document, right?
in the document.
Yeah,
Yes.
yeah, of course.
Okay.
Everything is far apart. So basically, the thing is that there is no relation with the query, because query is something that the user is asking. Correct. A
Yes.
user can ask anything that is in query. So what happens here is, which is actually been followed everywhere as a thumb rule, that you have an approach that is called cosine similarity, right?
Hmm.
So cosine similarity is the fundamental of all of the vector databases. Sorry. So what we do here, we find the similarity between the query and the vector. Okay. So let's say my query is, I'm looking for a wildcat, and I have vectors around the vector dimension that I have got, right? And I'm querying from that vector dimension. Now,
Yes.
if I am matching that, that means I will get a vector that is matching the query. The closer that document is, the top results that I will see, I mean, that again depends on what top we are selecting. Now we are going to reach to the closer to the query. So we'll try to return the query that is the document that is closer to the query. Make sense?
Okay.
So it doesn't
So from
matter. Yeah.
what I understand, it is basically you're assigning some values to the query,
Hmm.
right? And then creating another feature vector in that landscape, and then trying to see how close we can go to that query, right? Is that what we are trying to do?
Okay, so basically, if you understood the cosine similarity functionality, which is the goal is to match a similar vector, right?
Yes.
So now you have a vector store where you have stored a lot of vectors, right?
Hmm.
Now you have a question. So if I have a matching query here, I'm going to get that,
Okay.
right? So the
Yes.
LLMs, when you ask a prompt in
Hmm.
ChatGPT, what it does is it internally converts your prompt into a vector, looks for the similar vectors that is being embedded in that model, and it's going to return the more, I mean, so LLMs are much more powerful than just returning the what is matching as a vector. It also
Yes.
has the generative nature, because we are using decoder only models. So decoder
Hmm.
only models are actually generating a contextual vector which is matching with your query. So if you remember the transformer architecture, in the decoder layer, we actually pass, so we get the K and V, which is the attention vectors, and along with a query, that query that we pass in the decoder layer, and we add it to the multi-head attention here. So QK and V, if you remember that QK, and we apply softmax on top of QK into V and divided by the vector dimension D, right? So generally in the BERT world, it was our vanilla transformer, it was 64 it was the dimension was 64. Okay, but right now we are actually going beyond that and improving and increasing the size of the dimensions. So this is where the dimension comes into picture, the vector and all those stuff. Okay, and the QKV stuff, right?
Okay. Yeah.
Are we good?
Yes.
All right. So Milan asked how the dimension is decided from a given dimension is like, so it's like you are going to build a building, right? What would be the dimension of the base building is decided by the architect, and the amount of space you have, the amount of money you are going to spend. So it's not about like what should be, there is no fixed size, but these architectures are built. Let's say transformer was built, and that was the dimension they decide. Now over the time there are different LLM models coming, they are also changing the dimensions, they are making as per their need, as per the requirement, and also they see a suitability that improves the model ability. Make sense? All right, so let's go back to the paper now. All right, Gecko. So a Gecko is a compact and versatile text embedding model. That is basically the idea behind this Gecko model is it achieves strong retrieval performance by leveraging key idea. So I forgot to tell one more thing here. So when we created word to vec, right, we took all the data from Wikipedia. Now you tell me, when we actually talking about these kind of cosine similarity and trying to match the context and so on, if I have a embedding model that is trained with Wikipedia data. All right, so this is an embedding model, let's say, and this is trained on Wikipedia data. Now I have another model, another embedding model that may have trained on, let's say, all the chemistry or chemical compounds. Okay, embedding model. Now I have another embedding model that may be trained on, let's say, market analysis. I took all the data from market-based analysis, and I have created an embedding for that. Yeah. So now, now I'm looking for, let's say, I'm asking a question, what's the distance? So this is my query. What's the distance between sun and the moon? Okay. Sun and moon. Will I get the answer? There is
I
a probability that we would not get anything good, right? This is, so maybe the Wikipedia would give us something, because Wikipedia has that sun and moon related information, maybe. But if we go a little bit deeper, let's say, tell about the molecules and the fusion in sun, what is happening, and if that data is not there in any of these embeddings, we are not going to get that answer. All right, so what I'm trying to refer here is the embedding models are so much dependent on the domain that they are trained on, or the task that they are trained on. Okay, so if I have trained a model that is for sentiment analysis, targeted for sentiment analysis task, it is good at sentiment analysis and nothing else. Make sense?
So in this is one quick question.
Yeah.
Let's say that I have a Wikipedia, right? And I have embedded with BERT. Okay. And I have used BERT for one thing, and I might have used some OpenAI embedding for the same Wikipedia. Okay. Right. So does it matter when I'm trying to retrieve and I'm using when I'm doing my query? Let's assume I have embedded that with a different embedding.
Yeah.
So does it kind of matter? Because is it required that the vector database, with a model with which I have embedded the query, should also be embedded with that, or it can be a different? Hope you are getting where I'm coming.
It definitely matters a lot, but you will not see a lot of difference because most of these models that we are using today are too much generalized.
Okay. Yeah.
And that's the problem, this why this Gecko model came up. And what they are trying to propose is, instead of using one model that is generalized, not focused on anything, but rather they came up with a model that can focus on multiple tasks, and they actually got different set of data set that they have trained on. Now the problem when they build these embedding models, right, the problem they had is they cannot get task specific data. It was challenging task. Like if you have to get marketing, sales, and all the stuff related to different type of fields and train a model, it is very difficult actually. So they came up with a synthetic data generation, and that's the point here. Yes, Vaibhav?
Yeah.
Can you hear me?
Yeah, I can hear you.
So now what I understand from this is, for a generalized model, it will take the average of the entire data set and give you. So that is the reason the context specific, the task specific embeddings, we won't get a richer representation of a downstream task, I think.
Perfect. Yeah. So actually it depends, it totally depends on what is your business use case. And if you are too much in domain specific queries, then it is not going to work, because embeddings are not going to work. The generalized models are good till some extent, but they are going to be like, like we do this rag and all those stuff where we actually store these vector embeddings into a vector store. Now how good what is the quality of those vector embeddings, that is dependent on the embedding model that we are using. And that's why we are talking about the set of, like you pointed, set of models that are very, they are basically the set of models that are generic, and the set of models that are very specific, and they have targeted NLP tasks that they have got trained on. So Gecko is one of the model that is Google has introduced. So they are actually proposing that instead of generalized model, Gecko is using this LLM based retrieval, LLM based prompts, or I would say LLM based generations, to use building this kind of embedding model, which was not possible earlier. So our two-step distillation process begins with generating diverse synthetic paired data using an LLM. So they are actually generating a set of data from LLM, and then they are training an embedding model. So that becomes a little bit easier to do or build such models. So we further refine the data quality by retrieving a set of candidate passages for each query and relabeling the positive and hard negative passages using the same LLM. So the fundamental idea here is, instead of getting data, curating it from open source data source, or let's say Wikipedia kind of stuff, which is very generalized data set, they are using LLM for generating specialized data. So the effectiveness of our approach is demonstrated by compactness of Gecko on a massive text embedding benchmark, MTEB. MTEB is one of the popular benchmark for the embedding models, like we have MMLU for LLMs. Gecko with 256 dimension embedding dimension outperforms all existing entries with 768 embedding sites. So Gecko with 768 embedding dimension achieves an average score of 66.31, competing with 7x larger models and 5x higher dimensional embedding. Now, you might have seen that we have discussed earlier also in Llama 2 and Mistral, right? Are you guys aware of Mistral? So Llama 2 and Mistral is Llama 2 70 billion parameter model performs lesser in a lot of cases than Mistral 7 billion parameter model. Why so? What is so much difference in the same? So one model that is 7 billion parameter model is competing with a 70 billion parameter model. Can you see this? How this difference is coming? Definitely, there is a lot of difference that the quality of embedding that we actually generate to train or to basically train that model. Yeah, Waiver DeepMind is one of the best when it comes to generating and utilizing synthetic data. Yeah, they are doing good work there. Yes, Waiver Patel. When will this video upload to YouTube channel? Okay, I think question to Vivek. um, but
Yeah,
sure.
try to do it, within 1 or 2 days. Yes.
Yeah. Correct. Mistral has divided. So they have different strategies. These models, why they are being different and a little bit more successful is the different strategies that they are following. But remember, all the root of all these LLMs is I I actually I actually picture this always in this way, that if you have a big LLM model, right? You have built a big LLM model, which is a tree, right? And the root of this is embedding. Root of your LLM is the embedding model. All right. So text embedding models represent the natural language as dense vectors. Positioning. I already showed you guys what is a dense vector. Positioning semantically similar text near each other within the embedding space. Like we saw cat and dog, king and queen being placed in the similar dimension, similar space in the embedding dimension. Sorry. And these embeddings are commonly used for wide range of downstream tasks, including document retrieval, sentence similarity, classification, clustering, right? All this stuff. So instead of building separate embedding models for each of these downstream tasks, like say for sentence retrieval, for document retrieval, for similarity search, for classification, we can't build many embeddings, and also it is very cumbersome to. It is difficult actually, and I would say it doesn't make sense, right? Let's say you are using LLM, and you have OpenAI is providing your, let's say, LLM providers is giving you 20 different embedding models to convert your embeddings based on your use case. That's kind of very messy, isn't it? Right now, what they said, okay, there is a generalized embedding. You use it for all your purposes, and that's what we are doing for all our use cases. We have a text embedding model. They are improving over the time, but that's fine. But this is what we are doing. And I mean, honestly, I don't want to comment on that because I'm not sure that I haven't seen that what data they have trained these embedding models on and how they have trained it. I don't have the details, or I haven't read it, at least if anyone knows here, because that matters a lot. What data they have got, how they have trained this, how they got the embedding models. Okay, so the recent development of general purpose text embedding models present a challenge. That's what we're talking about. And these models require large amounts of training data to comprehensively cover desired domain and skills. So recent embedding efforts have focused on using extensive collection of training examples. Like LLMs offer powerful alternatives as they contain vast knowledge across various domains. So now they are actually using these LLMs, as these LLMs have a lot of understanding with different domains. They are actually trying to generate synthetic data from LLMs specific to a specific domain, using that data to train an embedding model. Clear? Any questions, anyone so far? So what they do?
So, Indrit, what you're saying, the paper is saying that for a specific domain, they are generating data or other content, and they are using that to embed it again.
Correct.
Oh,
correct. I will show you guys a diagram here that will clarify it. If you look at this, right? So, it's basically using this versatile text embedding model that is trained on variety of tasks. So they are actually they are getting this, let's say task is give a query, find a passage that answers the question, when is the feast of S.T. Herman, right? So now we are getting this to Gecko model. Similarly, like the answer is positive and negative for the answer that we got, And that's what we are feeding into the Gecko model. And we can also have similarly multiple tasks, like this is a sentiment task. We can have classification, we can have document retrieval, and so on, right? And we get using fret method. This fret is the technique of retrieving documents from the LLM. So they are using LLM for getting this task specific data. That's what they are feeding into the Gecko model to create an embedding model. Make sense? Yes, Vaibhav.
I was wondering where does the negative come from? Because the task does not mention that you have to output a negative pair as well. So is that something?
Sorry, your voice is very hazy. It's not coming clearly to me. And last points at least.
Okay. So can you hear me now?
Yeah, I can hear you.
Okay. So where is the negative pair coming from? Because the task does not explicitly mention that that you have to output a negative pair. So is that something I'm missing?
The task, so basically they are identifying it. I will show you guys that how this is being used here. Right now it is, this image doesn't tell you that. Using the research papers, they don't really do a lot of details there. Not a lot of details, as much as possible, right? So
Okay. Okay.
I will talk about that later when I discuss further on
Yeah.
this. Okay.
Yeah. Okay.
So by combining LLM generated and LLM ranked data with human annotated data, our model Gecko 1 billion with 768 dimension embeddings achieved the best performance on the popular MTV benchmark among the models with compatible embedding dimensions. Okay, that's the idea here. Okay. There are a lot of related work, like I was talking about SBERT. SBERT has been very popular and was good. I have also used for so long, in 2-3 years in a project I have used SBERT. Is really a good model. And then we have universal sentence encoder and sentence T5 attempt to provide general purpose embedding suitable for various NLP tasks. So despite attempting to be general purpose, studies indicate that these embedding models struggle to generalize across tasks and domains. This is one of the challenges that Gecko model is solving here. So motivating the creation of unified models trained across diverse tasks and benchmarks such as MTB. Okay, so this is the text embedding models that we have. We had a related work like contrastive learning. Contrastive learning is like proposed to select hard negatives from a large corpus using asynchronous updated approximate nearest neighbor index. These are different algorithms. I'm not really going into that depth right now. Similarly, we have the other areas. So this area, synthetic data generation, is, I think, 2-3 years and even before, a lot of organizations, a lot of models, a lot of research papers also came in that was focusing on synthetic data-based model training, right? Even during BERT 2018, when I was working on that, there were a lot of challenges that, we do not get real data. And one or primary question that starts, before we actually start doing fine tuning with these models was like, can synthetic data do good for that? But in a lot of cases, we have no choice. We have some data, maybe let's say 2,000 sample or 1,000 samples, and we need minimum 5,000 or 10,000 samples. So we actually generated some synthetic data from that. Now, that time it was not like we don't have LLMs, so we cannot create domain specific data. It was very challenging. But now with prompt, we can do that. And so this area is what is the related work that has been done before as well. And then we have retrieval and instruction. So previously, some of these papers that demonstrated that there exists a different intent for different retrieval tasks. For instance, given a search query, users might want to find similar query, or they might want to read passage that directly answer the query, isn't it? So the recent work has explored implementing retrieval that changes retrieval behavior for different intents. Real intent is what we are actually what we are trying to get from these models, right? So we are introducing retrieval with instructions, where dense retriever is trained to follow an instruction that was given along with the query. Also explores how LLMs can generate synthetic task instruction and associated queries, But for more general purpose text embedding similar to ours, they use two-step prompt to encourage the diversity of the synthetic data. So it is also an art, like how you use these LLMs to retrieve and write down right prompts to get a relevant data, get this data set prepared for building your embedding model. Okay, so now they have discussed about training recipe for Gecko, which is like pre-fine tuning step where you use self-supervised tasks over large text corpus, and that text corpus is like a training mixture. Then we have training objective, because you need to have a objective for training. In Word2Vec, what is the objective? To basically a neural network, right? Embedding models are also a separate neural network that is having given a task. The task is to, for Word2Vec, it was the task to predict the next sentence given a word, or predict the next word given a sentence. There was two models like CBAO and skipgram, but that got advanced into GenSim and fast text and so on. Here also you need a task. Sorry, here also you need a task to generate that, which is the training set, training mixture. So the training with a training objective. So pre-fine tuning on large amount of unsupervised text pairs has been shown to improve performance for smaller scale dual encoders for various downstream tasks, including document retrieval, semantic similarity, and so on, right? So the goal of pre-fine tuning stage is to expose the model to large amount of textual diversity, which seems necessary for compact text embedding models that we aim to train. Okay, makes sense? I'm not going into this mathematical equation here, which actually uses similarity, like the cosine similarity. So here we also have two vectors that we are trying to find similarity, and then we have a fret. The fret is a two-step.
Sorry, in that above paragraph, they were saying dual encoder. What does the dual encoder mean? Don't mind.
Two different. It's basically parallel encodings, right? So two different models that they are parallelly trying to work on. With a so what happens is, like, if you have one task to train with it, the model is basically training with only becoming aligned with one singular task. But if you have multiple tasks, I have to use a dual embedding model, and that's the goal here. There is a detailed research paper, if you wanted to read about. I will share that dual embedding. Yeah, so can go into that detail later. Fret. So Fret is the major core of this, or I would say the primary core of this, what is being used, right? So in this, they have used a novel method for generating synthetic data for training multitask embedding model. They used a Fret based technique, which is basically this synthetic data generation by prompting the LLMs. Okay. For example, given a query, find a passage that has the answer to the query. Question answering, right? Given a query, find a passage that allows you to check whether the query is true or not. Fact checking. Similarly, given a query, like Vaibhav had asked right earlier, why it is positive, negative. So given a query, find out if the answer is positive or negative, right? So the model has been given that prompt already. Now you keep on giving the queries, and it is going to tell you the positive and negative and that kind of sentences. Okay, so now look at this detailed diagram here. I have a web, so I am asking Fastos, a character blazed with the power of invention, helps humanity create the atomic bomb. Now you feed into the large language model. The task is, given a query, find a passage that answers the question. Query is, who made the atomic bomb? Similarly, there is another task. Given a query, find a passage that allows you to check whether a query is true or not. Similarly, I can do many tasks like this, right? Sentiment and document retrieval and so on. Getting it, Vaibhav?
Yes,
And
yes,
then,
I like that. But I was concerned with where did they come up with the negative, pairs in during the synthetic data generation.
yeah, the model is getting that. So you have a
So
query, you have a retriever, and then that is good. Sorry, there was a question.
Yes, yes. But the task does not mention that you have to output a negative pair. So how do they do that, I was?
Paper. So they will give as much as data as possible there. So they will not give a lot of things, but given that they don't want someone to get it. Yeah.
That makes sense. Yes.
We have been, doing preparation at Cellstart from like I think around 2016. At least I am doing from 2017 when this, attention is all you need all these papers came in. But we always have seen that these challenges are there. But nowadays, at least researchers are a little bit merciful to us, like, the layman's like us. Uh,
Okay, merciful. Okay.
yeah, because they are not using very, you saw a little bit of math there, now that too similarity. There earlier it used to be a math that you need to probably work 6 months to understand that math. It used to be like that. So, but anyways, maybe I either they are very merciful, they are not adding that mathematics here a lot, or we become little bit understandable. Okay. Anyway, so with that task, by sampling over such free from test task description, we guide the LLM to produce a wide range of pairs. And these pairs are later used to train embedding models, teaching the model to associate a query and corresponding instruction with the target passage. Make sense? So I'll quickly jump into the results. Gecko 1B 256 dimension model, they are saying the highest, they got the highest scores or good scores with the MTV result. 1B 768 dimension is definitely better than the 1B 256 dimension. So that the higher the dimension is, the model is performing better with the MTV data. Okay. All right, so that's pretty much it. I'll share the link for the, paper if you guys wanted to read it on your own. But given the timeline, I wanted to conclude here. Do you guys have any questions? Let me know.
Can you very quickly summarize, what we have discussed very briefly?
I'll do that, Vivek.
So
So,
we can have questions
so,
as well.
so as a summary, we can say that this Gecko model, which is little bit advanced embedding model than what traditional embedding models that we see with OpenAI and all. We are using a technique with LLM based synthetic data generation to generate domain specific data, and then we are training this model on specific domains to with a single model with a specific domain data, and we are creating a specialized embedding model that are focused towards multiple different tasks. Okay, so that's what we primarily discuss, and this is the architecture that we have demonstrated here, that the freight model and also a task specific data. Yeah, cool. So that's a quick summary of it. Vaibhav, you have any questions?
Yes, I'm sorry for asking too many of those. And can you go back to the self-supervised part where they do the pre-training of the model?
You mean this one, this part?
No, not this one. Pre-training.
Okay,
Where
okay.
the
So I think the training script where we were talking about, right?
yes, the pre-training part.
1 second, huh? I'm going there. Yeah.
Okay. So the pre-training task, I'm not getting what is the objective here? Because it's not mass language modeling, it's not the next token prediction. So what do they do? Like how is it self-supervised in the context of cosine similarity? So is the details given out in the paper?
No, so basically the you mean the objective, right? So
Yes, the objective.
yeah. So basically they use a cosine similarity model with a temperature parameter, and we do not utilize hard negatives during pre-training. So there is a hard negative and soft negative that they are actually using here. That basically the idea here is to maximize the batch size that fits into the device. So this has to be like, there is more detail on these different paper references, but if you look at this particular option, right, QI and PI,
Mm-hmm.
and PI is taking a mean of, as you said, like two different tasks, right? So it is basically multiple different tasks, and the mean of those weights of 2 different tasks or 3 different tasks. That's what is an average that they are getting using QI and PI. Okay, so they basically prepend a data specific task feature before each query. So each query is informed for which task is being optimized for. So they are trying to optimize based on specific query that is been. So they are actually using LLM for a lot of these task specific training here. It's not word to vec, because we kind of advance from there. I mean, we can't really relate with word to vec or next word prediction kind of stuff.
Okay. Yeah.
Yeah. So
Thank you.
similarity is one of the major goal here that they are trying to find. All right. Gaurav.
Yeah, so can we go to figure 1? I just have a query in it.
Sure.
So
Can't hear you, Gaurav. Gaurav is.
hello?
I can hear you now.
Yeah. So I might have misunderstood the model, but from what I understand, it is basically taking large language generated data and also its rank, and then it is putting it into this FRET basically structure, and then it is getting data, right? Is that correct?
Yeah.
Yeah.
So the synthetic data is getting generated from large language model. FRET is the kind of an proposed architecture that referring to. It's a fancy term, but it is primarily like, you know, getting query and specific task specific queries that the results, yeah, from that.
Okay. So
Yeah.
basically, can we say it is recycling the same data from large language models to fit the vector space? Basically, it is using large language models to create documents which are much more aligned, and then getting data from those documents. Is that what is happening?
I like the term recycling. It's like, you know, yeah, this, let's say these LLMs are like dump yard of a lot of textual data from the web, and they are getting the refined data from it, and they're using that for the embedding model. Makes sense. Yes.
Yeah.
Okay.
And yeah.
So we are going to close in another 3 minutes. So I saw an answer for the Siamese. So guide PMPP, the name. Sorry, I don't know what's your name, but this is the right thing. So, you know, Siamese is one of the very popular technique even we use in few shot and zero shot learnings, and that helps basically, especially zero shot, not few shot. But so because in few shot we don't really train the whole model, we actually take 2 different models outcomes. Like, let's say Vaibhav is saying it is right, and let's say Gaurav is saying it's not right. So if you have 50% or 50% probability of getting it right, if I have 2 models that are getting same answer, then we can say 100% probability it is the same, right? This Siamese kind of network, which is the dual embedding nature that they are talking about. So with that, I would like to summarize here, and I hope you guys have a lot of learning. And thank you so much for attending this.
Okay, thank you, Indrajit. Thank you, audience, for joining. A very nice session, Indrajit. Thank you very much. Any final comments by anybody before we close this webinar?
I had a small query. It is kind of out of the general topic. So can we say, like, what would be better, using language model data or using human data, right? Like, which would be better for training LLMs? Would it be to directly recycle those data, recycle documents, or would it be better if a human wrote all those documents in person?
Obviously, Gaurav, obviously, if a human wrote it, that would be better, right? But the
That
thing
would be
is that's a lot of cost. Google
Yeah.
and Microsoft, like companies, are struggling for it. You can't get thousands of people like quality data from it. It's a lot of things. But so they actually have a mix. LLM generated responses. Nowadays, LLMs are doing good, so we are using it. But I'm not sure that how far it goes, because humans cannot be compared with LLMs, no matter what. So
Okay.
Thank you.
Okay. Thank you all. So with that, we'll close this session. Thank you all for joining. Thanks a lot, Indrajit, on bearing this on a short notice.
Thank you.
And hope to see you all in our next webinar, which actually starts in another 1.5 hours. Thank you all for joining. Thank you, Indrajit.
Thank you, everyone. Take care. Bye.